So just to give a little bit of background for people who didn't join, last week we started with a tour of our platform, looking at the main components, specifically the structure of our platform and the architecture. We had a lot more to talk about, so we decided to split it into a second session this week. I'll hand over to Jay.
Thanks, Nicola. We can probably just kick off. So in our previous session, Nicola's covered the product line capabilities, core architecture, and the part we never got to was positioning and where we fit within the architecture stack. So part of this is probably not unique to architecture per se, but to an entire market will decide what kind of product eventually fits and where it doesn't fit. And I'll be taking you through kind of two parts of that story before we get into the more technical details. The one is just to take a stab at how we see the industry's platforms evolving and the current state looks like of how companies have slotted themselves into the industry stack. And if you think about, often the industry stack is created by the level of investment needed for you to be able to compete. OpenAI raising 5, 7, 10 billion at a time with a valuation that is astronomical. The only way that it can compete with Google is to be able to drive that level of investment to get the people in place. So that means that if you want to compete with somebody in that industry or that level within the architecture, you probably need to raise an equivalent amount of money to build out a core platform. Then you look at some of the standards that people have shared already in the industry and where we fit on those particular frameworks and why we decided to fit where we fit, because it's quite important for our clients, and especially when people also decide on architecture, to know where we fit within a broader technology stack. We'll go through a couple of the concepts of how we fit into generic technology and architectural environments. So if there is a Kubernetes or cluster configuration, why would we want to use those, and where does it play in the bigger scheme of things? If we take the industry and the business architecture and the technical architectures of these companies, you'll see that there are 3 pillars and 2 pillars in this table. The 3 pillars on the left are companies who build and create software products as their primary means of earning an income. The 2 columns on the right are companies who use people who have built software and provide consulting and other services around it. So that means that if you are an AI SaaS product vendor, it basically means that you rebuilt common AI tools. If you look at the amount of money that companies have raised, like Midjourney is the only one that have raised the least amount, but all of them are raised in billions. They are vendors that sell their generic service to various companies, including enterprises. So that means their architectures are designed to deal with mass consumption, complete openness, and in all cases in that particular pillar in the AI world, all those companies revenue by convincing people to provide them with data continuously. Like when you use a prompting environment in the license agreement, you'll see that all of that will be used eventually. So they gain access to that. In the AI product vendor is when functionality is pre-developed or tooling is enabled, and there's thought leadership and the specialization of what you focus on. Even in this space, you get a number of horizontal and vertical architecture. So even ecosystem fits in that particular pillar. We are an AI product vendor, and that means that companies like H2O, even though they are also a product vendor, we use some of these other open source products to create an ecosystem of technologies. So the architectures in this space are often open source, often enterprise only, or in some cases, especially from a first built environment, maybe available as a container. It means that there are various architectures that are definitely not the same as what you find in many other architectures. The platform vendor is an area where companies spend billions making sure they can drive the most horizontal platform across everybody that engages with it. As an example, we would use technology provided by a cloud provider, but we won't build anything to compete with them. So how do you decide is the big question. In the AI and consulting world, especially in the tech consulting, what is happening from a consulting point of view is that almost all consulting companies are starting to do tech work, and they are dropping some of their advisory return for technology-related activity. And doesn't matter if it's Deloitte or the McKinsey. Even McKinsey, the latest report showed that almost 50% of their global revenue comes from technology projects. That is quite different than what we used to see historically. AI management consulting are companies that help organizations, and they obviously don't care what architecture. They just want to sell the consulting project. So whatever becomes popular in the vendor space gets sold. As a vendor, our architecture, that means needs to be, designed in a way that can be integrated and utilized by enterprise companies, and also where you have access to many different capabilities like libraries and the like, that will enable you to train a team, to build internal skill, have access to a partnership network that understands an architecture, because the architectures need to be flexible and they're deployable in various enterprise settings. So if you're going to compete in an enterprise space, you need to understand where you fit, because there are hundreds, in some cases thousands, of large organizations. Why would somebody decide that this particular architecture will work if you're going to create something that causes pain somewhere else? And you have to decide how that's. Okay, so if we then just look at it from a AI product consulting point of view and how the industry sees this, if you look at quadrant one, there's mostly tools and pre-trained tooling and vendors that are playing there. So some companies, used to pre-train models. These days, most of them are open source. The AI tooling world sits there mostly. Quadrant two is the quadrant that deals with, all of the how you deliver AI in the context of the value in a short term, and that means that is it a way that you can typically drive consulting and projects and everything? If you're a bank, have you got the capability of building everything yourself from the ground up? Quadrant three is where most of the activity is, and that means organizations acquire additional skills encoded in a product from a vendor. So that means that the architecture needs to be flexible enough so that when a risk committee, security committee, technology review committee, an architecture committee, whatever that might be in the bank, has to approve a particular change in where it's going, and that change is material into the architecture, it's going to assess the degree of risk that is involved in doing that, and it might delay or never get to a point where you can implement. If you provide an adjacent technology that sits alongside everything that is already supported in the bank, how do you then get that into play? And the idea is that we believe a lot of activity sits in that space. This means that by the time you decide where and how you compete, and the context of AI SaaS vendors, the idea is to provide such a deep specialization that you can scale it to millions, hundreds of millions of people using it, right? And the thing is that it's very generic and still needs a lot of work to make it specific. And that's where the second quadrant comes in. AI product vendors are the ones that actually make these things work for companies, and we fit there. So that means that we are a product vendor. You can either run us entirely outside of your current infrastructure, or you can run it in your tenancy. There are decisions that need to be made depending on the kind of organization, and you want to keep it as flexible as possible. But let's not get into more of the detail for today. We need to map this onto the broader industry. If you could call the AI world an industry, it's probably more an embedded sector, if you want to describe it technically more correctly. We have this very key dividing line. What sits below the dotted line are the breakthroughs and the platforms. What are the core inventions and the deep scientific research being done, funded by the larger organizations? Almost 90% of all AI papers today are published by a handful of companies around the globe, and almost entirely, if you look at the top performing companies that publish papers, are almost all American, California based. So that does create a kind of almost like an exclusive community, that if you want to then build a platform on top of what you've invented, you are in a position to do that because you got access to the first order skill that is worked on, say, a brand new algorithm for back propagation, but you want to make sure whatever you build is generic enough that anybody can use it. The only way to make platforms practical is to build platforms as derivatives on top of platforms. If we look at the ecosystem journey, that fits as a derivative in platform theory. It means that derivative has a capability to leverage what sits underneath it, which you want to buy or which you want to engage with a company that's going to give you something so unique that is completely proprietary and it can't integrate with anything you have. We know that era is long gone. So now everything is far more dependency-based than what it used to be. And then the support products in our world is what we call modules, or like some kind of solution that sits on top of our derivative that is a platform. That's why we call it the ecosystem platform, because you can deploy it with a worker architecture in various situations to do work for you without having to get a sense of lock-in or anything of the sort. You can still protect your own intellectual property. You can do all of the stuff that you need to do outside of the environments you're working in. Let's take a number of other companies that we've sometimes seen popped up. So if you look at companies like Iguazio, that is a McKinsey consulting sales machine for them. Yeah, Data Robot, H2O, SageMaker, Vertex, all of these companies are selling generic horizontal capabilities. So there's no, it's not in the interest for them to have any of the pure business functionality specific to certain use cases. And that means that they are designed to create tools for even companies like ours or any large organization who wants to build everything from the ground up themselves. And a decision normally needs to be made, how much of that gets done or not. If you think of the cloud providers and where they play, you obviously have many different kind of core capabilities that are already in place that you want to leverage. So if you had to think of an indicative description of it, we can get into the detail. A unified platform, an integrated environment. Yes, you want to be able to deal with real-time scoring, real-time inference, models that can converge, and you don't want to get out of your existing environment or drop everything that you've done historically. If you want to build a classical offline model, a static model, you want to be able to take those practices and harvest them and then have a capability that is specialized running next to it, but still be able to access it and make sure that it's accessible. And that means that data management and feature engineering are almost always part of your cloud environment and very well defined. In most companies already have plans in place. We help organizations to implement those, even though we have some of that capability in our product. And then a model registry, and depending on what kind of model, if it's a static model, you probably will end up using something like ML Flow that is used by basically everybody. It doesn't matter if you're in a cloud or not. Anybody that drives any kind of generic model registry typically will use generic open source products. So what do they bring to the party? We bring the metadata management and the abstraction of the project module that you can move around. And then model training and tuning. Is there a way that you can do tuning across multiple architectures? So can you do it in, let's say, a TensorFlow or an Azure, TensorFlow or a PyTorch or a H2O, whatever the environment you want to do it in, and be able to move those models around to put it into your registry or not. And then by the time you get to model deployment, how do you deal with low latency deployments? What does permanently in production really mean? And we have got that capability in place that all that you would have to do in the context of a cloud is have a cluster available that you can then push configurations to. Then monitoring. In a real-time world, everything is monitored end to end. There's continuous tracking of everything going on. Your CI/CD automation as well. How many steps can you remove from your CI/CD pipeline? And that is often the discussion, far more than how many things can you automate. You want to decide what can be removed and simplify and compress the delivery. And then performance, horizontal scalability, and scoring is almost always important. And then your specialization is that in our case, all the behavioral algorithms and everything and the core real-time scoring engine is a very, very key differentiator. The same with what happens with any of the modeling that we do in static or generative models. The metadata definitions of those allow us to move from one environment to another without having to create any risk for the client implementing that environment. And then the low-code, no-code scenario, ease of use is always an ongoing discussion. We've got Python libraries as well as front-end environment where people can go do what they need to do. Being agnostic of cloud and packaging your production focus, this means that can you get an architecture that gets deployed easily or at least in a simpler way than if you had to do it all yourself. Let's take a quick glimpse at some of the other architectures. If we look at the AI Infrastructure Alliance, this organization created a high-level framework and separated the data ingestion from the entire training pipeline all the way through to model serving and inference, as well as the entire data world that sits underneath it. And we don't build a notebooks platform. We don't build a data science experimentation platform. That's why you see our logos there. We do the data engineering engine. We use tools that are available, but we have created an experimentation engine. We've created a training engine that deals with either real-time or offline training capabilities. Deployment engine in production is called permanent production. Your serving engine is the heart of almost everything that happens in the AI world. And that means that, can I drive reliable inference against a model in production? The idea is that we sit in that space. We have runtime scoring engine. That runtime engine gets deployed alongside all of your other digital assets in your data center. By the time that is available, you can just push configurations to it and make it accessible. And for those who are interested, maybe we can pop it into the chat if you want to see what the Jupyter Notebook looks like in a session. Maybe just pop it into the chat, and then we can do that in a moment if people are interested. Then another technology stack that's popularized by McKinsey, they focus far more on generative-based models than a lot of the other frameworks. We don't do that. So that means that we use technologies that are accessible or open source tools that assist us with that. We don't do, generic security, but this whole framework basically assists you to understand how all the components fit together. Where we do fit is by the time you deal with data retrieval and the metadata definition. If you want to understand how infrastructure and cloud services are deployed, we have got a whole cloud deployment platform and application as a service environment, especially for things like semantic search and structured data search, and then the prompt engineering and the prompt libraries and all of the capabilities around your generative models. You want to be able to abstract it away from specific tools, more generic business functionalities environment. And we allow that to happen in the workbench and inside our environment. If we then look at another model that has emerged recently, is the one called the Generative AI Reference Architecture approach. If we did walk through the different areas quickly, you've got a Gen AI platform portal. So what we see companies are asking about is there a way that I can access a catalog of all the models that are accessible to me? How does that work and where does that fit in the context of my business? I want to have a place where that can be defined. That normally happens in a portal. Then in your documentation base, your platform operations, your AI learning, all of your capabilities that you want to define in the context of your overall documentation, even if those are accessible through a generative model. It's inside block A. B is about your static compliance and the automation pipelines that you have in place. I think with big models, if you're going to train them or you move a lot of data around, you're probably going to have a pipeline architecture to handle that. It's pretty important that you get that in place. And then C, how do you deal with your solution use case definition? Where and how is your use case defined? And how do you document it by the time you get to a place where it's going to be deployed? And then how do you add foundation models are normally provided by your big tech providers? They will provide you with various ways that you can access it through APIs, and you can bolt it straight into the environments that you're using. Like if you use ecosystem, you'll be able to add that quite easily. If you look at block D, it's around analytics, logging, monitoring, and how you get your entire generative process to make sure every single prompt in your company is indexed, documented, and logged. That will hopefully get you to a point where you've recorded everything you need in that space. Let me just park there for a second. Let's look at the two questions. Does this deployment architecture support both real-time and batch processing? Do they follow the same pipeline flow? I can get you that in a moment. I'm going to show you in the next couple of slides what we see from a kappa and a lambda architecture. So we normally being quite different depending on the situation that you're in. And the second one, I'd love to see a demo on a notebook action. Okay, let me get a couple of concept slides, and then we can get into some of the technical stuff. Eric will demonstrate one of the things for us and maybe show OpenShift running, and we can have a look at what it looks like in a stack environment. Okay, at the heart of any reinforcement learning environment, you need to have an approach where the outside world gets connected to your inside world, and almost always you'll see that there's a separation in the real-time and the more static data, because the cost of managing data in motion is typically pretty expensive and often quite challenging. So the real-time feedback and the data that gets generated then to create models, in many cases, could be done in an architecture that is offline, and I'll show you a few patterns in a moment. But it just means that in a real-time feedback environment, you probably will end up having different sets of architectures. In our last session, we did discuss this, but maybe just to give a quick reference point again, operational data to use during your test phases or pre-production environmental reviews or if you're going to want to check ethics or other issues in the context of models you've integrated, all of those normally would happen in different environments. And in our case, you can literally replicate this architecture across a number of different clusters. It's pretty easy to separate your configurations for your project so you can move them around between different implementations. So you could configure a case on the local beefy machine and apply that into your organizational setting and get it deployed. Or you can put it into GitHub and then get a response back. The other thing that affects the architecture quite significantly is how you wire various runtimes together or various inference engines together, where the output of has the input to the next, and or the one sets the context for the next, or there's memory that you want to keep on a context of a chain. So that means that when you do your architecture, you typically want to have an understanding of what your context is within which you're deploying everything. The other thing you want to have a good understanding of is the data pipelining. And in our world, we normally kind of need two kinds of data, data sets as input and the rest generated by the interaction engine. You typically need a customer definition, and on the other end, what the product is, what you're going to sell, what your message is, what you're doing with this particular environment that has been spun up. And then interactions and responses are all generated for you. So that means that the data architecture for us, being streaming, being high speed, and so on, being configured in a separate environment for performance is normally a prerequisite for getting our kind of architecture working in a real-time world where you have a very low tolerance. So that just means what we discussed in our last session is the fact that the way the runtime engine is configured. Slides popped up. The way the runtime is configured is you have the ecosystem platform in the back end, and you've got a business interface that could be any of your channels, or it could be your dashboarding. We provide dashboards for real-time feedback out of the box. We provide different apps, libraries, and pre-built code, access to API and your business interface. And in the back end, you can spin up our environment you would have in your test environment, in your dev environment, in exactly the same engine. And the configurations can evolve from one to the other as you work on your use cases. The architecture will use existing pipelines that you have inside your cloud environment to, in some cases, move metadata from one place to another. At the heart of this, you have the permanently in production. And the permanently in production means that you typically will spin up a cluster with a number of runtimes. They'll stay in production and they will have a common configuration. So that means that, let's say you have a use case that's going to decide how to converge on an advert on a screen, a banner that appears, a new item that needs to be shown, a list of items that appear at the bottom of the screen. If they click on a button, and you've got 7, 8, 10 different cases configured, and you want to deploy those cases. In our world, what you normally do is you decide its load and its velocity of interaction, and then allocate a pod with a scalability to that particular case, and then allow it to scale on its own horizontally. Or what you might end up doing is just have many of these in production with minimal requirements configured, so that if a person like a data science or a machine learning engineer wants to use the ecosystem server, they can literally work on, let's say, a development environment like IntelliJ or Microsoft or one of those kind of development environments, push their code, build something, and then have it immediately accessible by that cluster through the pipeline that already created. That's part of our deployment. You can use Python libraries and so on that we've pre-created to do all of that. So that's permanently in production. If you get into generative models, things start being quite a bit. Now you've got the complexity of wanting to make sure that you separate your backend into 3 distinct layers. We almost always see that there are 3 layers, or at minimum 2 layers in the architecture. Almost all AI-related products are accessible through an API of some sort, or even if you think of the latest standards, E2E or MCP, all of them have some kind of API interface that you can do it and then deal with a JSON payload that can be moved around. So that means that the touch point being an API is now a pretty defined standard for you to access almost any model. And then the backend, if you wanted to replace your OpenAI access and you want to bolt somebody in the middle that will pass the exact on but log in the process and add intelligence and do fact injection, you can then connect to our server, and we have got a completions endpoint that makes it look like it is an OpenAI environment running. But as a business, you now have control over what kind of messaging is sent, what people are sharing, what kind of facts are being responded back to them, depending on what we inject into the environment. So there's a whole lot of different options that can be configured. And then the notebooks and the algorithms that are deployed are mostly Python libraries. All those libraries are published open source, or in some cases, we've created some specifics for the modules. On our backend, we separate the chat, in some cases, another server engine, depending on how you want to deal with generative log, and then the broader world of prediction as a service in a far backend. So if you wanted to run, let's say, an Llama stack with a model in your own data center on your own cluster, then what we still recommend is that technically and architecturally, you want to isolate those servers from everything else that you do. Even if that server is entirely private, the compute requirements and the way that it gets accessed and what you want to log while calls are being made to these environments, especially if you're inside an enterprise, means that you want to keep that as a separate infrastructure. Typically with large compute, high CPU, specific configurations where the chat engine in a vector store needs a lot more storage and less compute. So if you have a data injection pipeline where you bring data from all over the company and you want to allow people to access it through Copilot or through a generative front end, or use an open source front end like Library Chat, you want to be able to do that at a separate layer, because the velocity of data that moves and compute on the database is far different than what you're going to need for your model. And then to run all of your pipelines, you separate those out as well. In a cloud environment, we'll use services in your cloud world. If you run it on-prem, you will have to decide how you separate the design across these different environments. By the time you want to deploy it, if you look at the block right at the bottom, the client path responder, the recommender that runs means you can access the runtime in the context of an MCP, so a model context protocol. It can be bolted into any of your agentic journeys, or the runtime itself will do scoring in a number of different ways, depending on what the use case is that you're busy working on. So it just means that, and again, I'm not going to work through the table in detail. For those who want more access to this, contact Rob or Madison, and we'll make sure you get access to this, especially if you want to know more about how this can be used in your environment. There's a composed service and different types of pods descriptions typically set up in a cluster. The runtimes are normally scaled horizontally, and sometimes the server is scaled vertically depending on what load it's got. So there are different configurations that need to be applied from an architectural point of view. And that means by the time you create a business design that you want to deploy the architecture into, you often include things like where would you use like the ecosystem network environment, or how would you do experimentation, where would the data feed back to, how would it interface with your digital roles, and that normally gets done in the context of the architecture teams when we define it with the architecture teams. The other thing is that when you set up an entire agentic journey and you want to include access to APIs and other parts of the data needed to get the journey to work, the security and everything needs to be taken care of in the context of that journey. So your security architecture and what people are allowed to access is journey dependent. You'll often will see that architecturally, we want to make sure that we define it there. Here's an example of a bunch of recommenders and offers and banners and all kinds of different use cases that you maybe want to push into production. As they go into production and you select whatever algorithm you're going to be using, you then deploy it in an experimentation environment. You want to be able to have configuration ABC, different runtimes in different environments, and you want to have a network selector that can decide where and what needs to happen, or not necessarily decide on its own, but you can configure it in a way that will either use a model or a lookup or some capability to decide where it needs to go. So that just means that up until this point, everything I've told, that there's abstraction, there is a parallelism to what you're doing already, there's an embeddedness in the architectures that are available, and what we maybe just can show you to make it practical, and I'll go into some architectural patterns. I can maybe ask Eric to show what an actual example looks like, what a pipeline would look like if it had to run. Maybe just a short view of that. Eric, will be good.
Cool, no problem. So I'm just going to show an example of a notebook that's running a pipeline to push the deployment to Kubernetes. We call it a pipeline because that's the standard terminology, but it's kind of a one-step pipeline. So it's a pipeline in name, but maybe not in philosophy. The pipeline is the same across whatever environment. So, I'm showing it for Kubernetes now, but you'll see I actually reference Kubernetes specifically. It will work the same way.
We're only seeing your video.
I'll switch over to the notebook now. I just wanted to give some context.
Okay.
This notebook is kind of environment agnostic, but it is going to point to this Kubernetes environment and do the deployments there. This is an example of this dynamic interaction case using the ecosystem rewards algorithm. There's some preamble to import our packages and connect to our ecosystem environment. Here we connect to the server and specify, what projects and case we're wanting to work on. So we're going to look at this interaction science rewards. Here's the part where we reference Kubernetes. You want to point to the endpoint, your permanently in production endpoint that you have set up. So whether that's in Kubernetes, Docker, or OpenShift, or EKS, or wherever it is, you're going to have some endpoint for your permanently in production runtime. In our case, it's this service we're pointing to, and then you authenticate to that endpoint, so we can connect to that. I won't go through this piece in detail, but you can do the configuration of your intelligence, whether that's training a static model, setting up an ecogentic framework, or doing a dynamic interaction configuration. You tell the runtime what sort of intelligence you want and how it should work. So here we're saying we have these different messages we want to recommend, learn about dynamically, use the ecosystem rewards algorithm, and have these learning parameters and contextual variables. And then you configure your deployment. So in this case, we're going to link our dynamic interaction configuration that we've created. That's just creating this deployment multi-armed bandit. And then we want to look up our data from somewhere to know about the customer we're interested in. So here we configure our parameter access, just like our customer feature store. We're going to look up customer feature store from our interaction science database. Our lookup key is going to be customer, which is an integer, and we're going to look it up from MongoDB. That configures that, and then we set the rest of the parameters for our deployment. We give it a description and say what pre and post score we want to use. So this is logic that you can customize as a developer. The Mongo connection we're going to have, here we specify our parameter access and our dynamic interaction. So we can create this deployment. All of this can also be seen in the workbench. It's a bit easier to visualize here. They're just kind of different ways of engaging with the same functionality. What we've done here is Kubernetes. With this interactions, we've created this setup. We've said which pieces of functionality we want to use. We've configured our endpoints and our database connections, and then we've configured this database lookup using dynamic interaction configuration and post-score logic. If you want to have custom Java code, so here your kind of post-score is doing a bunch of work, taking your scored results and looping through them, checking eligibility, and if the results and ranking them and all those sorts of things. If you want to put something custom in here, normally you would have a whole like Java build pipeline then. Instead, on the workbench side, you can use this compile button to show it in Python. There's this generate class function which will build for that individual class. So this is kind of your pipeline. Instead of your traditional pipeline, you have your permanently in production runtime, and then you do this generate class to build your custom logic. So all that we're doing here in this cell is we get the details of our deployment steps. We're basically getting this configuration. Then we get this code, this post-score class code that we have linked to it. We compile it and generate the class, which will be given a unique name, and then we save that back into the deployment step. If we run that, which is kind of running our pipeline, we've now compiled this Java code into this class and save that to our deployment. And if we now want to configure our production endpoint to use this new class and all the other parameters we've given it, we use this process push function. this will send a properties file to that endpoint, and the cell will also just print it out just for reference. So you don't need to do anything with this. It's just for information. And then we can check a kind of real-time call to that endpoint using this configuration. So are we getting ranked recommendations for those messages for this customer? So the endpoint is now going and looking up the feature store for this customer, applying the dynamic interaction rules and ranking the messages, because we said we want one offer, it's returning the highest ranked one, and saying that we should talk to this customer by saying, get 10% off your next purchase. That's the offer that we should make them. The pipeline is actually very simple. You basically do this, generate this class based on your code you've written, and then do the process push, which will send this properties configuration to that permanent production runtime. That's the deployment pipeline and the notebooks. So if there's any questions about it.
I think the comment maybe for people who are not involved in pipelines will know just how profound it is, because the amount of work that you normally have to put in to get these things to work. And I think that biggest thing is the reduction of the steps in the Python environment that creates an entire situation, so people don't have to worry about the complexities. Okay, thanks, Eric. So let's just then wrap up with a bunch of architectural patterns, and then what we will do.
Question, well, a comment. Sorry, the Workbench setup looks great. Really excited to see Olana supported for local LLMs. The demo of the notebook and deployment pipelines was also very impressive.
Thank you.
The thing to think about, especially when it comes to running generative models, is that when you configure it, it's never in isolation. If we think about other models and how we configure it, we'll talk about that in a moment. So let's look at the first pattern around the unified data infrastructure. If you have data sources that are either OLTP, so that means online transaction processing, high speed and high velocity, and you've got slow moving environments like ledgers and daily updates, you normally look at all those as sources, and the language that often gets used in a data world is called source and sink. If you think of Kafka, or especially when there are streaming elements needed in your data environment, this means that you want to be able to have a series of steps that can be executed so that at the end of this, the data that is accessible either support a medallion or other kind of pipeline architectures, or it might be a kappa order that we'll talk about in a moment. So this means that you want to be able to follow a series of steps. What we can do, Jess, is make this available for people maybe when they request it, or when you post the video, maybe just put a link there to say that they can request these examples. So what it means, the ingestion can come from various patterns, but you want it to deal with all the stages you normally need to go through, especially with larger data sets where petabytes are involved compared to smaller data sets. You have a different set of configurations to worry about. And then by the time you then think about the analytic, what are the reporting requirements, how will people access it, and what are the rules around that. And then machine learning infrastructure is almost always in parallel to your analytical infrastructure, because your analytical environment, the data is prepared and is organized often to deal with the performance on the use of it. So if you're going to produce a set of results on a dashboard and you want to count how many orders were done yesterday or the day before, or how many transactions took place, and you want to have that as a sum that can appear on a dashboard, should you dynamically calculate that every time with all the compute that is associated with it, or would you cache that out or save that out, have a separate environment where you deal with aggregations? I don't want to get into the basics of BI or any data intelligence world, but that's a very different requirement, because in machine learning, almost all of your data is vectorized, encoded, or object-based. So that means that models only really understand numerics. You have a very different kind of data pipelining environment that you need, especially by the time you create feature stores. If you have data labeling that needs to be done, and then you want to do an encoding, and from the encoding you want to be able to then go through certain validations or auditing. A lot of these steps are followed because you are creating new things and you're creating new data on the fly, and it's not the same as in your analytical world or in the previous conversation that has been through. And eventually what you want in integration You want to be able to access it from wherever you have deployed it into. Ecosystem fits in here as well. We fit under the low code, we fit under the data pipelining. We rely on a lot of these pipelining and access to your data coming through the architecture that you have in place. Then, if you think of then the focus areas of the analytic versus operational, the make data-driven decisions on the one end versus your machine learning on the other. This means that there are different requirements for those. So the blueprints could look like what we call modern business intelligence. This means a BI layer where you take your data, you replicate it, you have a warehouse style. So that means that you aggregate, you sum, you prepare a certain set of data points before the time so that if it's accessed at scale, it's done far more economically than if you had to do it in real time every time. And that means it often ends up in your data warehouse. Look at the multimodal data processing. This is where things get a bit more difficult because now you have both text and Parquet and Avro and various data formats in the mix. And that means that a lot of those might need individual processing, where in this case you also have access to your real-time analytical database or your real-time feed. And even if you use Kafka feed environment or you use Spark-based feeding environments, you're still going to need a way to be able to persist the data to get it into a stream that is accessible by whatever the scoring engine is that is going to be using it later on. So that means that the multimodal just means we take real-time and offline images and text, you would need a different set of steps. And some of the most important aspects of your AI and your ML environment that people often forget, you follow a very similar structure to your machine learning, generic process flow, but you want to always think about model diagnostics. And we know that we've got questions coming in from clients asking, is there a way to make models using AI more explainable so that even a business person can understand it? Can you take different kinds of convergence approach to explain those? One of the environments you can use for that. Pre-trained models is also a big bit, and pre-trained could also mean that you have an algorithm that can be used in your business to supply a far better result. And then your validation and auditing, and you can then put all of that through again into a way that it's accessible with APIs or some kind of app framework or a vector store, depending on what your final deployment is going to look like. So I guess in a nutshell, those are the architectural patterns. And the thing about architectural styles is that you want to be able to decide on what kind of approach you follow that must be holistic. So the approach you're going to follow probably will relate to your online and your batch and all of the ways in which you engage, not just with the way that you're going to use recommenders or your financial transaction systems. So if you have a real-time and a batch query reporting, real-time feeds, structured and unstructured data, you've got a lot of human-machine interfacing, whatever it is. Lambda is typically the architecture, and the same as with Kappa. Kappa is just a real-time only architectural style. And then Zeta is also a great style because it's very much designed around social media and multi-graph structural interfaces. Microservices, we all know what the microservice architecture, and actually, in fact, you often will implement the microservice architecture inside all of your other architectures. Data is an approach that follows generic data or small data sets at a high velocity. The last three are the ones that almost always get embedded. They're not really an architectural style, more so than a data style. If you look at the lakehouse architectures that are emerging at the moment with Delta Lakes and the like, this means that you have to decide based on the size of your data and the rules under which you're going to act, how you would want to design whatever the outcome is for that. So a Lambda architecture means that you design real-time and batch. And an example of that could be Netflix, where they've got a real-time environment as you browse through your options, and they've got a batch environment that updates what people have watched in your area, what the common genres are. They run independently, and there's a number of different technologies along the entire stack to make sure that all the data sources come from various places are consumed in the right way, in the right velocity. Then a Kappa architecture is when you turn almost everything into a serving layer that is real-time or streaming. Uber uses that architectural style. There's a continuous feed of data from all over the world into Kafka. There's an ingestion into a format what they call hoodie. That's essentially a insert a difference only in a data lake. Basically an Hadoop-based style of insert using Parquet. All of that can end up in a Spark, a Presto notebooks, or a high front end, or a high storage, whatever that might be for access for accessibility. And the thing is that this data environment is 100 petabytes, and it is way bigger than that now. But just to give an idea of the velocity of data coming through streaming. Lastly, when you bring all of these together, you often think of a speed layer. You've got your applications, your sensors, everything that provides events that come in. When those events come in, they are persisted, but at the same time, they're scored. So in our world, we believe we can implement any of these architectural styles. So we can fit across almost any of them. We have the right abilities, and the architecture is designed to be deployed across any of those environments. The part that we are going to get to today that maybe at a follow-up, Jess, we can discuss with everybody, is to look at different architectures that deal with on-site, off-site, and to have a conversation about the various cloud providers, like where would ecosystem fit in the context of, let's say, a Microsoft Azure, when you spin up a cluster, how will it be deployed by the time you drive us in the context of your data lake? How do we fit in that world? You almost always see the Azure architecture will have like Cosmos DB and access Cosmos directly, depending on your compute requirements, but the same pipelines can apply to us. In AWS, architectures are pretty well defined these days as well. A cluster that you spin up and you publish the API through your API layer, people to access, and you can still use all of your existing reporting and access to your Bedrock for your large language model directly in your cloud configuration. By the time you start using Athena and so on, Athena is Presto under the covers. We use that, and we probably will end up fitting next to your SageMaker environment if you want to do score, if you want to put all your scoring in the same environment. And for Google, very much the same as everybody else. They all follow the same pattern of implementation. Maybe business logic you want to bring in other parts, but in our case, you'll spin us up as a technical tool that runs inside your environment. All these services are accessible in both directions, depending on what you want to do with it. The idea was just to give everybody a glimpse of the extended architecture from our previous session. We wanted to get into more technical detail today, but I think we can do that in the future. If you think of the Python libraries and so on, for people who are interested, they can request those from us, and we have published a lot of those through the system algorithms, notebooks, or Git repos. Yeah.
Absolutely. Okay, cool. I think that's a great close to the session today. This recording will be available on our YouTube page under Architecture 102, which is the name of it. And then just to mirror what Jay was saying just now about revisiting some of these concepts as we go along in this tech series, we will be encountering or interacting with different categories. If you see anything that's part of the foundation category on the invite, it is likely to be a follow-up on an Architecture 103. We're quite eager to move on and to do a couple of more episodes and then get into the real nitty-gritty parts of it. So in the next 2 weeks, our next session excuse me, will be ecosystem, another foundation episode, and it's going to be about the workflow. So it's going to be talking about, to build on what we've been speaking about in terms of how ecosystem fits into any different environment. We're going to be talking about the kinds of flows you can have while using ecosystem within whatever environment that you're in. And this will run all the way from hypothesis or concept all the way through to deployment and how it can be managed in the after effects as well. And that is going to be in 2 weeks' time. Jay will be running that session as well, and we'll see you guys there. And yeah, like Jay said, if you've got any questions, you're welcome to comment on our YouTube page on the videos. You're also welcome to send an email to one of us. I'm probably the best option for that. So it's jessica@ecosystem.ai. We look forward to hearing from you guys, and send us questions, please. Thank you all.
Thanks so much.
Bye. Cheers.